Greetings again, this is Scott, known as Cantaloupe to some online, here with the final video of the 5-part series of how to create the Platonic Solids in the HTML5 Canvas API. This is going to be an overview of the icosahedron, which, as I've been describing, is a fun shape to program, and you'll see why in just a moment, so let's do it. So this shape is one of the ones that is very easy to program with a particular method involving the golden ratio, which you may be familiar with. It's closely related to the Fibonacci sequence in that as you start with 1 and 1, you add those together, you get 2, and then you add 2 to the last number, which is 1, you get 3. Add 3 to the last number, which is 2, you get 5, and so on and so forth, and you end up, this is called the Fibonacci series, so 5 plus 3 is 8, 8 plus 5 is 13, and so on, and you end up getting some fairly large numbers fairly quickly, and after, say, 40 or 50 iterations, you end up with two very large numbers that, if you divide the last one by the second to last one, you get the exact golden ratio. It's a number 1.61 something something. It's found in architecture, it's found in nature, it's found all over the place, and it's an amazing number. You can create the golden spiral with it, the golden rectangle, and you can create an icosahedron, which is very interesting. So I just did a little code in the console there to do basically what I just described. I've just had, it's a one-liner, you make an array and you just loop through it, adding the last number to the previous number and then divide, and it spits out this ratio, 1.6 whatever, and I just copied and pasted it into this new function. It's the same idea that we've been doing for the last 4 videos, called icosahedron, and I'm going to make a golden rectangle. First, I'm going to start with a single golden rectangle. And the way you do that is you take the height. If it's going to be a horizontal rectangle, you take the height of 1, or multiplied by whatever size that you want it to end up as. And then the width is going to be this ratio. So it's 1 by phi, or however you say it. It's a Greek letter. That's the golden ratio. So it's 1 by 1.61, etc. So, and then what you do is you just take that same rectangle and you rotate it about each axis, or about each plane in the 3-dimensional space that we've been just talking about in these videos. So that's what you see on the screen right here. I've done that very quickly. This video is also sped up. It's going to be a little bit shorter than the last one because it's kind of more straightforward. I'm using a similar technique to the last video where I mark the vertices of each corner with the index of that corner, so that I can see visually which number of the iterators correspond to those corners. So, and I'm doing that so that I can actually just really quickly go down a list and connect those corners. I just pump out 20 polygons. It's almost tedious. It's so easy. So you make a golden rectangle, you rotate it, and if you can figure out which corners are which, you just line them up and create 20 triangles out of it, 20 equilateral triangles, and it just works out to be an icosahedron at the end of it, which is really cool. So the triangles, there's 20 of them, as I said. So it's an icosa, which means 20. And the way I'm doing this is kind of super easy, because I add to the interior of each triangle a very faint semi-translucent or transparent color, which if it's overlapping any other triangle, you can tell instantly, visually, that there's either an error or it's how it should be. So it's kind of a really handy technique to just bang out the polygons really quick, and then at the end of it, if it looks right, on the screen, you just count your rows. There should be how many? 20, right? So that's exactly what I'm doing here. I'm just connecting the dots. That's all it is. And like I said, it's almost tedious to do this. It's not even really a lot of mental grunt work in it. But at the end of this, what I do is I uncomment the other shapes that I've been creating in the series, and the animation you see in the intro and the extra or outro, I just align them in that kind of configuration, and you'll see shortly here the icosahedron's done, and then all the shapes together. I do a little bit of resizing. I just want them all to be pretty much the same size, and you can, I mean, if you needed them to be an exact volume, that would be something else, but for this purpose, it's okay to just eyeball it, and I do that sometimes. So and then the last thing I do after all of that is I make the colors different per shape, like they should be per the animation. And it's almost done. The icosahedron's done. And as I described in the previous video, I had some scaffolding left over. I used some scaffolding in this one as well to do all those vertex connections. And I had to delete that, so that took just a second. And then here I'm creating a little bit of new code. This took me just a few minutes to create an array of shapes, because I hadn't actually done that. I've just been forking the project from the previous video, and there was nothing to begin with, so I have to add anything that is needed from scratch. So I'm doing that really quick. I'm adding a little bit of logic to populate an array called shapes, which each element is a shape. Makes sense? And there you have its own. There it is. There it is. So you'll notice the cube's a little outsized. It's kind of too big. So what I do is I'm just fine tuning, kind of a little OCD stuff here. Not really, but the cube needs to be a little bit smaller. It was bugging me, so I fixed that. And then the icosahedron's looking just a little bloated. Now I fixed that, and that's it. That's the end of the series, and that's the end of the icosahedron, and I thank you very much if you joined me through the whole thing, and I look forward to the next presentation. So reach out if you have any questions. Have a great day. Thank you.